Just as we can have issues with static routing and IP version 4 networks, we can have IP version 6 static routing issues as well. And that's what we want to talk about. For one thing, when we give the IP version 6 or IPv6 route command, we might specify an egress interface instead of a next hop IP address. We said that was a problem for IP version 4 primarily because of ARPs. We don't use ARPs in IP version 6, but we're about to see that's still going to be an issue for us. Or we might be exhausting the cache, the number of entries we can put in our NDP, our Neighbor Discovery Protocol table. Before we get into the specific troubleshooting issues, though, let's take a look at how we configure a static route for IP version 6. We see the syntax on screen, but let's go out to a live interface, and we're going to be using this topology we see on screen. We're going to be over here on router R1, and we're going to want to set up a static route to get to the IPv6 loopback IP address of router R2, which is, let's see, what is it? It is 2007::2222. Let's take a look at router R1, and let's see right now if I have any routes. Do I know about any routes? Well, I did a show IP route. We need to do a show IPv6 route to see our IP version 6 routes. And that brings up an interesting point. A lot of the show commands we use with IP version 4, we can use equivalent commands for IP version 6 simply by replacing IP with IPv6. For example, instead of doing a show IP interface brief, I could do a show IPv6 interface brief. Instead of doing a show IP route, like I did here, I could do a show IPv6 route. And here we don't have any statically configured or dynamically learned IPv6 routes. Let's create one. Let's, well first, let's see if I can I ping 2007::2222. That's the IP version 6 address of router R2's loopback interface. I don't think so. There's no route to get to that IP version 6 address, so we're going to go in and create a static route. Let's go into global configuration mode, and we'll say IPv6 route, and we're going to say 2007::2222, and IP version 6 addresses are 128 bits in length. And that means if I'm trying to specify a specific IP version 6 address, I'll use a 128-bit subnet mask. That's similar to using a 32-bit subnet mask with an IP version 4 network. And to get to this network, which is just a specific IP version 6 address, I'm going to specify a next hop IP address of router R2's Fast Ethernet 0/0 interface. We can see on screen that that has an IP version 6 address of 2002::2. And I'm going to not give an administrative distance. I'm going to use the default administrative distance of a 1, but just be aware that like IP version 4, we could specify a non-default administrative distance. Now let's take a look at our IPv6 routing table, show IPv6 route, and we can see this newly configured static route. Let's see if this lets me get to the loopback address of the IP version 6 loopback address, that is, on router R2. Let's do a ping to 2007::2222. And this time it is successful because we've gone in and we've statically configured an IP version 6 route on router R1. Now let's take a look at some troubleshooting issues that could arise with IP version 6 and static routes. For one thing, when we're creating a static route, as we just did, instead of specifying a next hop IP version 6 address, I could have specified an egress interface. But we said when we set up IP version 4 static routes that was not a good idea. And one of the reasons we said was it could create an excessive number of ARPs on a broadcast interface. But hold on, IP version 6 does not use ARPs. Do we still have an issue? Yes, we do. We do not want to specify an egress interface in our IP version 6 route, static route statement typically. And the reason is, even though we're not using ARPs, we are using something called NDP, Neighbor Discovery Protocol. And the thing to know about NDP is that it is link local. Link local means that this address is only usable on this directly attached link. And this could lead to us not being able to discover other networks. If we send out a neighbor solicitation message, as an example, we may not get, in response to that, we may not get the neighbor advertisement that we're looking for because NDP, Neighbor Discovery Protocol, is link local. How do we fix that? Just like we fixed it for IP version 4. We can go in and we can negate, we can use a no command and we can negate the existing IP version 6 static route, put in a new IP version 6 static route, but this time let's specify the IP address, the IP version 6 address of the next hop, as opposed to an egress interface. Another issue we might have is that the Neighbor Discovery Protocol, or the NDP cache within a router, fills to capacity. We have a cache for each interface on the router, and different router models support a different number of entries in that interface cache. As one example, a Cisco Nexus 5500 can hold 6,500 entries, but let's ask ourselves, is it possible to have more than 6,500 IP addresses as part of an IP version 6 network? Typically, yes. Typically, we have a 64-bit network. 64-bit network, let's see, that's 2 to the power of 64. That's a lot more than 6,500. An attacker could maliciously flood our NDP cache with lots and lots of entries, overflowing that cache. How do we prevent something like that from happening? Or maybe it just happens naturally because we've got a lot of devices off of that interface. One way to eliminate this issue is to increase the size of that cache. We could do that with this command. We could say IPv6 ND cache and specify a new interface limit. But another approach is to simply prevent us from having 2 to the power of 64 addresses anyway on that subnet. We could, or not a subnet, but on that network. We could have a longer prefix. Instead of 64 bits, here's an example where we could go in and say that our IPv6 addresses, they're going to use 120 bits in their network prefix. That would vastly reduce the possible number of valid IPv6 addresses that we would have for an IPv6 network. One word of caution though, if you're using Slack for your IP version 6 addressing, there's a requirement. It requires that we use a 64-bit prefix length. So if we are using Slack, then going in and using a longer prefix, that would not be an option for us.